The Smiths Cloud is a high-velocity cloud of hydrogen gas located in the constellation Aquila, and it is speeding toward a collision with our Milky Way galaxy. This cloud provides unique insights into the dynamics and evolution of our galaxy. Understanding such cosmic bodies helps astronomers piece together the complex processes that shape our universe. The cloud was discovered in 1963 by an astronomy student at Leiden University in the Netherlands. The cloud, called Smiths Cloud, contains enough hydrogen to make 1 million stars like the Sun. It is 11,000 light-years long and 2,500 light-years wide, and it is only 8,000 light-years from our galaxy's disk. If the cloud could be seen in visible light, it would span the sky with an apparent diameter 30 times greater than the size of the full moon. What makes Smiths Cloud unique is that its trajectory is well known. Currently, the Smiths Cloud is situated roughly 40,000 light-years from Earth. However, it is moving towards the Milky Way at nearly 700,000 miles per hour. Scientists predict it will collide with our galaxy in about 30 million years. This future collision is an exciting event for astronomers, as it can provide a real-time example of how such interactions shape galaxies. There are several theories about the origin of the Smiths Cloud. One theory is the galactic fountain model, which suggests that gas is ejected from the Milky Way's disk by supernova and then falls back down. And it is estimated that it had passed through the disk of the Milky Way some 70 million years ago. Another possibility is that the cloud is accreted from the intergalactic medium, meaning it's gas captured from the space between galaxies. A third theory proposes that the Smiths Cloud is a remnant of a dwarf galaxy that was absorbed by the Milky Way. Each of these theories provides a different perspective on the cloud's past and future. The Smiths Cloud is significant for several reasons. Its upcoming collision with the Milky Way could trigger star formation, giving us a rare opportunity to observe this process in action. Additionally, studying the cloud helps us understand the broader mechanisms of galactic evolution and cosmic recycling, where gas is continuously cycled through stars and interstellar space. This process is essential for sustaining star formation over billions of years. The Smiths Cloud is a remarkable astronomical object that offers valuable insights into high-velocity clouds, star formation, and the evolution of our galaxy. Its study not only enhances our knowledge of the Milky Way, but also contributes to our understanding of the universe.